Welcome to another episode of Sound Talk Show. We are going to do Advent of Code 2025, Day 3. We started yesterday, but I got a call, so I have to go. So we aborted. So we're gonna continue yesterday. Advent of Code Day 2025, Day 3 in Wolfram Language. If you are watching this offline, play at 1.5 speed. If you are watching this here, post comment, okay? Love to see your comments. So let's see. Let's begin. So let's start Wolfram Language, the most powerful programming language. And I have tutorials. Just search for it, Wolfram Language for programmers. You'll find complete tutorial and where to download for free. Okay, so Wolfram Language, new notebook, evaluate 3 to start the kernel, and magnify. So we got a notepad going, okay? So Wolfram Language. Now my keyboard, let me show you guys my keyboard. My keyboard, this is Ultimate Hacking Keyboard 80. I have reviews on YouTube, okay? So video check, audio check. Okay, this is not good here. So I need to bring this up somewhere here. Video check, audio check. Okay, let's begin. So yesterday the problem was Advent of Code 2025, Day 3. The problem was given a list of numbers. For each number, you want to pick 2 digits in the number such that the 2 digits combined forms a number that is a maximum. Okay, so for example, 9876 something. In this case, the answer would be 98. 9 and 8, then 98. So that is the largest 2 digits number you can form out of this number. So the algorithm would be first pick the largest digit in the number, but not the last one, not the last digit. Okay, then pick a largest digit from the digits that is after the digit you picked. Okay, so let's code that. Okay, so let's say this example. So first of all, you need to pick a digit. So this is normally a string, but you can, so in Wolfram Language you can deal with string, or you can deal with a number and take digits. So let's see. So let's see all functions that whose name contains the word digit. Shift enter. So you got a huge number of functions whose name contains the word digit. Let's do it again. So it's 2 columns. Okay, so far so good. Comments, guys. Let's see. That is my Twitter. Okay, Wolfram Notebook here. Here. Okay, so FromDigits, digit signature, digit block. So digit characters, digit Q, real digits, FromDigits, integer digits, number digits. Okay, so let's look at integer digits. Gives a list of the decimal digits in an integer. Okay, let's just try some of it. So if you give that number, what does it return? Okay, that return integer digits. That's what it does. Now what is number digits? Returns the digit corresponding to 10 to the powers n in real value number. Okay, not sure what's the difference. Oh, this is a new function, number digit. Let's see. This is a new function in the past 5 years. Does it say new in 2021? That is why my Wolfram programming language mod doesn't have it syntax colored. So let's see what it does. I think it's the same thing. I think it's designed for floating point weight code with one argument. So it needs 2 arguments. So let's look at the detailed documentation. Okay. Return the digit corresponding to 10 to the nth power in the real valued number. So yeah, so this is designed for floating numbers, I believe. So if we can look at some of the examples, 1, 2, 3, 4, 5, 2. Okay, so it picks a digit. Okay, it picks a digit from, you know, a position in a digit. Right, so it allows you to pick one digit. Okay, let's ignore that. So integer digits, you want to find the maximum, the first one, except the last one. Okay, so you drop, so that returns a list. You drop the list. Let's make it one something smaller. Let's say 1, 2, 3, 8, 9. Okay, let's say that number 91238. Wait, let's try a different number. Let's say that 81239. Okay, then you want to drop the last digit. Okay, drop. So look at the documentation. Drop gives the list with the first n element dropped. Give the list with the last n element dropped. Okay, so drop that. Drop the last one. Okay, 8123. Okay, so then you want to get the maximum. Okay, let's see the documentation. Max. Okay, that would be 3. I mean 8. Okay, then you max, then you you pick the max. You need to know position. You need to know where is the position of the largest number. Then you need to remove everything, all the digits in front, because you need to pick the rest of it. Okay, so that would be position. Now let's make this interesting. So let's make this number, let's say 78129. Okay. Okay. So okay. Then what do you get? Then maximum is 8. Okay, correct. Then position, you want to know position of the max. That would be 2, the index. That's right. Okay, so then you want to drop. Then you want to drop drop the original from 0 to that position you picked. Okay, so what is the give a list from element m through n dropped? So you want to drop the first n element. Okay, so that would be basically 2. Okay, basically you want 2 here. Okay, then you pick the max, which is 9. Okay, then you pick the first number. The first number you picked, what is max? 8. So the answer for this number is 89. Okay, 89. So you got the digit 8, you got the digit 9. Then you want to make it into a number. So you want to turn a list of digits into a number. So how do you do that? Let's see. That would be FromDigits. Okay, click on that. FromDigits, construct integer from list of its decimal digits. That's right. Okay, you can look at the full documentation here. It's 125. Okay, so that would be from digit 89, you got 89, 89 to 89. Okay, so that is effectively how we solved it. Okay, so let's see. So input a list of numbers, argo step. So these are the steps. So now we just need to combine these steps into one function. So let's write a function. Okay, define. We can define a function extract big. Let's say extract max 2 digits. Okay, let's name it that. So that is a function we're gonna define here, and the function input x is a number, and what the function does is this bunch of things. Okay, we're gonna combine them into one thing. Okay, so before we do that, let's make a example. Wolfram Language, so you can see syntax correct showing browser. So here is today's code, and now let's put this example case into a independent example. Okay, so actually, okay, now syntax showing browser. So here we have an example. We want to extract, given a number, extract 2 digits such that they form a biggest number. Okay, and then we start to code Let's start to code. Okay, so here is the function. So given a number, so integer digits, this is just x. Okay, so what we want to do, okay, let's say block. Block is a local variable, so we create local variable here. So digit list equals to that. Okay, then what you want to do is you drop the digit list, drop the last one, then you apply maximum. Okay, and this expression can be written as that. Okay, so let's write it as, so you max drop, then so this can be first, make it easier to see. My hands type too much is got problems. If you are here, comment. Okay, am I going well? Let's see, where's my YouTube? 3 people. Okay, say hi. So back to Wolfram language, we are coding this, almost done. Perfect. Okay, so extract. So first, then okay, so this is our list of a list of constants. Okay, so let's not put value there. Let's just give a list of constants. Okay, so x digit list. Okay, then first digits. Okay, then you got the first digit, then what? Then you want to take the position. So this max is just the first digits. Now let's change it to, leave it. Okay, so position, and here is the x digit list. Okay, so that is the position of the first digit. Then you drop then you drop 2. Yeah, so that's the position. So this would be x digit list. You drop. Okay, so you drop. So the first digits that actually return a nested list. Okay, max. Then position returns a nested list with 2 braces. Okay, then you drop. Let's look at the drop documentation comments. So drop, let's see. keep a list with element m through n dropped. So first to that. So what you want to do is that here you want to say flatten. Okay, flatten. Then a list starting from the first one to this position. Okay, first digit position. Let's create another another local variable so that it's easier to read. Okay, first digit position. So now you flatten starting from the first to the first digit position. Okay, so that would be, you do that. Then you pick the max. Okay. Max at that. So this would be second digit. Second digit equals to that. Okay, so there's inconsistency naming, but don't bother. Let's move on. Okay, so you got first digit, then you got second digit. Then you just from digits x first digits. Wait, let's rename them. Okay, let's rename the first digit because that's too long. Okay. Let's rename them. Okay, then the second digit, let's rename them. Okay, save it, close, reopen, and now color them. Okay, now it's better. So digit list, first digit first digit position, second digit, then from digit would be just okay, so you got basically yeah, that's it. I think that's it. Let's shrink, let's prettify our code. Okay, that's the code. So if you have this function, you can call it. Let's see, we can try any of these number. A1, let's try this one. So this, okay, let's see if it works. Hopefully. Did I make any error? So let's maybe indent so it's easier to read. Let's just run it. 89. Fantastic. Now put a comma here so it doesn't show the value of the function. So run it again. 89. Fantastic. Now what about the first one? Run again. 98. That's correct. Now we can map this function to the list of inputs. Okay, so map this function to x input. Okay, so remove that, and that should be the result. Okay, 98, 89, 78, 92. Let's check if we are correct. Okay, then total 357. Let's total them up. Total Run it. 357. Fantastic and beautiful. So this is our code, Wolfram language code, one single function, okay? Now I used a bunch of variables, so it provides clarity. Otherwise, you don't need all those variables. You can like merge them into like one kind of cryptic, pure functional programming code. Okay, this is pure. This is supreme functional programming. In most other languages like Python, JavaScript, you don't have things like integer digits. Possibly Python has a library that added that for it's convenient for number theory kind of things. Okay, so anyway, so that is the result. Now we just need to put use the custom input. Okay, now put it back. Syntax correct. Show in browser. So that's today's talk show. First example, then our code. Now let's get our personal input. Get your personal input. Okay, a bunch of big numbers. Copy, no problem. Okay, 200 numbers, big. Okay, now you need to save this somewhere, so let's save it. Let's pick a name. Okay, something like that. So close, save it. The end of code 2025 day. What the fuck? What? Okay, let's try again. What did I do? Undo. Now open I/advent of code that. Okay, now input, copy, close. Now let's modify this. What? 2025 day 3 and text. Okay, let's see, input. Okay, so you need to say input, day 3 input. Now where's my, okay, there. Okay, copy that. Now save it by this name. Yeah. Okay, now remove that, save it, copy that. Wait, yeah, copy file path and link it. Let's see. Yeah, okay, so now paste that, and in fact let's just copy the code, the input here. Okay, so pre now here's our code. Okay, wait, so paste it and make it quotation mark none, separated by comma. Yes. Okay, then cut, paste. Okay, and remove the last comma. So this is our input. Okay, 200 lines, 200 numbers. Okay, now if we run this, let's just run it. Finished. Okay, you got a problem. This is not what we expected. Drop. What? Okay, it's a drop sequence specification. Expected position. Okay. What is the problem? Nobody's here. If you are here, say hi, okay? So sequence specification, drop sequence specification expected. So this syntax expected at position 2 in drop. So here is input. Then the second part is too long. That's incorrect. Wait, what is the second part? Okay, so when I call drop, so you can see, copy that. So here is it, okay? So basically, when I call drop, this is the first argument. Then the second argument I gave is this, which is incorrect. It should be one single number or at least one or three numbers, okay? So this is basically a syntax error somewhere in our drop. So let's open that. Open that. So where is drop use? So flatten 1 to digit 1 position. So oh, okay. So I think I got it. So when you say position of the digit, when you say, okay, digit 1, okay, so when you get the position of digit 1, if that digit is unique in the sequence, then you just got one position. But if the digit is not unique, let's say 2, there are many occurrences of 2, then this position result is a list of positions. Okay, so we only want the first one, the leftmost one. So basically what you have to say is you have to say position, return the first one. Okay, so let's see, pattern level spec. Oh, okay, pattern level spec n. Okay, so level spec would be level 1 and return just the first one. Okay, I think we can run it. It'll be correct. Run it. 17766 is our answer. Now, in case you are not familiar, let me show this again, okay? So position, okay, so position digit list, let's say, what? Okay, so let's say that digit list. Then let's say the first digit is, let's say, 5. Okay, let's remove that. So you see, 5 occur twice here. So normally, if you don't give optional argument, you know, it'll return basically, let's see, 1 and 2, 3, 4, 5, 6, 1 and 6. Okay, so let's try it. 1 and 6 in a nested list, you see? But now, if it occurs multiple times, then you get, I mean, now you say level 1, but just one item, you'll just return 1. Okay? Wait, did I did something? Okay, oh yeah, there's a semicolon. You want to remove the semicolon because semicolon, whenever you have a semicolon is a shortcut for compound expression. So whenever you have semicolon or with a new line, that is equivalent to this. Okay, so compound expression in Lisp is similar to Lisp's PROG. Was it PRO and PROG program? Okay, so anyway, so in this case, when you have a semicolon, this BB is omitted. That became null. So the whole thing just returned null because that's the last expression. So you don't want that. So now evaluate it again. You got that. Okay. Fantastic and beautiful. Okay, that's an explanation of position. So let's copy it. Actually, we done. Let's just post the syntax correct. Okay, that's our personal input, a big one. Then 17766 is our answer. Is it correct? Close that. Submit. That's the right answer. You are 1 gold star closer to decorating the North Pole. Continue to part 2. Okay, that shall be tomorrow. Maybe later today, but okay. So how are you guys doing? So you can join my Twitter. Where is my Twitter? Okay, Twitter here, Xali Twitter. That's me. That's me juggling back in almost 20 years ago. So you can join my Twitter. You can join my Discord, Xali Discord. We have all type of characters here. This annoying. So we are doing advanced code. Some people are doing it in Guile, Scheme, Lisp. And Emery Board is doing it in Common Lisp, I believe. Okay, so that's it. Thank you guys for watching. If you like my stuff, pay me, okay? So go to xali.info. Let me show you. XAHLEE.info. HTTP, no S. Okay, then go down. Then you go pay me, Patreon, Amazon gift card me, PayPal me. Okay. Bye, guys. We shut down in 1 minute. So let's see. Did we do everything we wanted to do? Day 3, yes. Correct. Simple problem. We need to fix this a little bit. So let's do that. Fix position of this list of this item, and at level 1, and return just one of them. Okay, put it back, syntax correct, refresh. Okay, fantastic. Now let's beautify this code. Can we beautify, like make it really minimal? Okay, we can. Let me just do that. Okay, pre Wolfram Language code. Okay, we can truly minimize this function. Okay, so let me show you how. So you got a bunch of first of all, let's color them. Let's remove redundant redundant unnecessary number of variables. Okay, actually this is good. Yeah, so our goal here is just to do some kind of pure functional lambda calculus play to make this function not use any local variables at all, yet remain efficient. Okay, let's try. Let's do that. This you can do with Wolfram language because Wolfram language allow this kind of thing. You cannot, you kind of can do it in Lisp, like Scheme Lisp, but not Common Lisp, not Emacs Lisp. In Scheme Lisp, you can somewhat do it, but not all the way. Let me show you. So this is pure functional programming. Remember, the goal is to remove any use of local constants or variables, including local constants. Okay, like no variables at all. Okay, so let's do that. Okay, how are you gonna do it? Okay, so wait, copy that. Okay, so it's digit list, digit one position. So position you can remove. Okay, position is used once. Okay, one variable gun. Okay, then this flatten, I like it to use the @ sign, reduce the number of nesting. Okay, then what you're gonna do is you can digit 1, digit 2. So from digits, digit 1, digit 2. Okay, easy. So digit 1 is used several places here. Okay, so from digits, that will be a function. Okay, so first of all, you need a function to okay, so y. Okay, so function that x. Okay, so then y, so then this is just y. Okay, so this is just actually okay, then this is digit 1 we don't need, then digit 2 we don't need. Okay, so then from digits, at that digit 1, digit 2. Okay, and this is the expression. Okay, so do you guys see what I'm doing? And you don't need the block anymore, so you got a pure function. Okay, can you guys see what I'm doing? Let me maybe syntax color, I mean pre-formatted a little bit. Okay, so you got and rename it. And wait, the digit 1. Oh, fuck. God. So the digit 1 is still there. That needs to be, oh shit, that digit 1. Hold on a second, let me not rename that. Okay, so that digit 1 there needs to be fixed. Okay, we can do that, but then the code becomes incomprehensible. It's already is incomprehensible. Okay. Let's see. Okay, so actually we simplified significantly. So we don't even get any. Can you guys see what I'm doing? Very complicated code. So this block is equivalent to this block. Hee. Finally, I got 2 comments. I'm doing AOC in my own Lisp dialect. Okay, that's interesting. That would be fun. Okay, so anyway, so now let's comment it out and let's run this. Let's see if it works. 357. Yes, it works. Okay, so you can see these two. Let me make a comment. This. Let me make a comment. Without using any local variable or constants. Alternative code, pure functional programming supreme. Okay, so that no local variables at all, but you do have like local parameter names. Anyway, okay, that's it. That's it. Bye.